Okay guys, welcome again. In this video I will discuss about DHCP attacks. DHCP or Dynamic Host Configuration Protocol is used to assign IP addresses to machines within any network automatically. Administrators do not need to assign IP addresses to machines manually. To assign IP addresses, DHCP makes use of DORA packets, which stands for Discover Message, Offer Message, Request Message, and Acknowledgement Message respectively. We discussed about DHCP concept and configuration by detail, and I put the link of DHCP video in the description. Okay? See, there are two types of DHCP attacks: DHCP Starvation and DHCP Spoofing. Both attacks are mitigated by implementing DHCP snooping. Okay, what is the DHCP Starvation attack? In this diagram, we have normal user to sending request for IP address, and this is the switch pass the traffic to the DHCP server. To perform the DHCP Starvation attack, the attacker sends tons of bogus DHCP discover messages with spoofed source MAC addresses, and the DHCP server tries to respond to all these bogus messages, and as a result, the pool of IP addresses used by the DHCP server is depleted. For example, the IP address of the DHCP server is 192.168.1.1/24 with a subnet mask of 255.255.255.0. So, the DHCP server can hand out 254 unique IP addresses. However, some IP addresses are maybe reserved for static routing, so it could be less than 254. The attacker sends multiple DHCP discover packets, whereas very large compared to 254 IP addresses. Hence, the DHCP server can no longer hand out IP addresses. In the other side, a legitimate user sends request for an IP address to the DHCP server and will not be able to get an IP address via DHCP. This results in a DOS or denial of service attack. Furthermore, the attacker can set up a rogue DHCP server to assign IP addresses to legitimate users. This rogue server can also provide the gateway router and DNS server to users. Now, all the network traffic can be routed via the attacker's machine. Okay, how to preventing DHCP starvation attack? DHCP starvation attack can be prevented by implementing port security. Port security can be configured in a switch. As I discussed in previous video, with port security you can limit the number of MAC addresses learned by the port. Hence, the switch would forward packets with known MAC addresses and discard others. This would prevent bogus packets from reaching the DHCP server. Okay, what is a DHCP spoofing attacks? As I said, after a DHCP starvation attack, a DHCP spoofing attack occurs when a rogue DHCP server is connected to the network and provides false IP configuration parameters to legitimate clients. As you see the diagram, this is a rogue DHCP server. The attacker can start distributing IP addresses and other TCP/IP configuration settings to the network DHCP clients. TCP/IP configuration settings include default gateway and DNS server IP addresses. Network attackers can now replace the original legitimate default gateway IP address and DNS server IP address with their own IP address. Once the default gateway IP address of the network devices are exchanged, the network clients start sending the traffic destined to outside networks to the attacker's computer. The attacker can now capture sensitive user data and launch a man-in-the-middle attack. This is called as a DHCP spoofing attack. Attacker can also set up a rogue DNS server and deviate the end user traffic to fake website and launch phishing attacks. What is DHCP snooping? To protect against DHCP attacks, DHCP snooping uses the concept of trusted and untrusted ports. As you see the diagram, switch to router 1 and the DHCP server are attached to trusted ports on switch 1. The other devices, including the wireless access point, are connected to untrusted ports. Trusted ports allow all incoming DHCP messages. Untrusted ports discard all incoming messages that are considered server messages. I think it is a powerful way to prevent DHCP attack. Untrusted ports apply more complex logic for messages considered client messages. They check whether each incoming DHCP message conflicts with existing DHCP binding table information. If so, they discard the DHCP message. If the message has no conflicts, the switch allows the message through, which typically results in the addition of new DHCP binding table entries. This feature optionally limits the number of received DHCP messages per second per port. For a Cisco switch, you can use these steps to enable DHCP snooping. Enable DHCP snooping by using the IP DHCP snooping in global configuration mode. On trusted ports, use the IP DHCP snooping trust interface configuration mode. Limit the number of DHCP discover messages that can be received per second on untrusted ports by using the IP DHCP snooping limit rate. Number interface configuration. This helps mitigate DHCP starvation attacks. Enable DHCP snooping by VLAN or by a range of VLANs by using the IP DHCP snooping VLAN in global configuration command. Thank you for watching this video. If you like this video, please subscribe my channel.